All right, welcome to the Explainer. Today, we're going to tackle a problem that every single programmer hits early on. How do you make your program actually remember stuff after you close it? This is the secret to making apps that don't have digital amnesia.
You've been there, right? You build a cool little to-do list, you type everything in, it works beautifully, and then you close it, reopen it, and poof, it's all gone. A complete blank slate. It's super frustrating, but it's one of the first major hurdles you've got to clear as a developer.
So what's the magic trick? Is it some super complex database, a fancy cloud service? Nope. The solution, especially when you're starting out, is way simpler. It's the good old, reliable, humble text file. This little thing is the key to giving your program a memory.
So, to use these things, we first got to understand what they are, and, maybe more importantly, how our code actually sees them. Let's break it down.
A text file is, well, it's pretty much exactly what it sounds like. It's a file with nothing but plain, simple characters. There's no bolding, no fonts, no weird formatting, and you know what? That simplicity is its superpower. Because it's so basic, basically any program on any computer can open it and understand it. It's the universal language of data storage.
Okay, this next idea is absolutely crucial to get your head around. When we talk about files and programming, we're really talking about two different things. First, there's the physical file. That's the actual clients.txt files sitting on your hard drive. Think of it as the real book on the shelf in a library. But then, inside your program, you create a logical file. This is just a variable. It doesn't hold all the text. It's more like the librarian's little index card that just points to where the real book is.
Okay, so we know what we're dealing with. Now, how do we actually, do anything with it? For that, we need a toolkit of commands to connect, read, and write to these files. Step one, always, is to make the connection. You have to use a command, something like assign file, to link your logical index card variable to the physical book on your hard drive. It's basically you walking up to the librarian and saying, I'm going to be working with that book over there. Once you've pointed to the file, you have to say what you want to do. You've got three main choices. You can reset it, which opens it for reading data that's already there. You can rewrite it, which is the dangerous one. It creates a brand new, empty file, completely wiping out anything that was there before. Or you can append, which lets you tack on new information at the very end without messing with what's already there. And then you have your workhorses. Commands like readl and writeL let you get data out of the file or put new data into it, usually one line at a time. And finally, and I cannot stress this enough, you must always close file when you're done. Forgetting this is like walking out of the library without returning the book. It locks the file, you could lose your changes. It's a classic rookie mistake.
Okay, enough theory. Let's see how all these tools actually fit together. We're going to build a simple, repeatable recipe for reading data right out of a text file and into your program.
The process follows this exact same pattern almost every time. 1. You declare your file variable, your index card. 2. You assign it to the real file on the disk. 3. You open it for reading. 4. You actually read the data. And 5. The most important step, you close it. Follow these 5 steps and you'll reliably get data into your program every time.
So here's the magic question. How do you read the whole file if you don't know how many lines are in it? This is the secret sauce. You use a loop that checks for the end of file marker, or EO file. This little line of code is an engine. It tells your program, hey, keep reading line by line and just don't stop until you hit the very, very end.
And that loop highlights a fundamental truth about text files. They are sequential. Think about an old cassette tape. You can't just magically jump to song number 5, right? You have to start at the beginning and read or fast forward all the way through. Text files are the exact same way. It's a limitation, but it's one you have to build your code around.
Okay, your code works perfectly, as long as the file you're looking for is actually there. But what if it's not? This is where we go from being a hobbyist to a pro. We have to bulletproof our code.
I mean, think about it. You go to open a file, but maybe the user deleted it. What happens? Boom! Your program just stops dead, spits out some ugly error message, and crashes. That's a terrible user experience. We can and we must do better.
You've basically got two great ways to handle this. The first is what I call asking for permission. You use a function like fileExists to check if the file is there before you even try to open it. The other way is asking for forgiveness. You wrap your code in a try except block. This tells your program, look, just try to open the file. If it works, great. If it fails, don't crash. Just jump to the accept part and handle the problem gracefully.
So, why are we going through all this trouble? What's the big payoff? It's this. We can now turn a file full of raw, messy data into something useful and beautiful.
This is what your data often looks like in the file. It's just a string of characters, maybe separated by commas. It's efficient for a computer to store, for sure, but for a human to read, it's not great. It's just raw data. This is our before picture.
And here's the after. Your program can read in that messy line, chop it up by the commas, reorder the name, and display it all in a clean, perfectly formatted report with nice headings. That is the whole point. We're turning stored data into valuable, human-readable information.
So when you learn how to do this, you're not just learning one more technical skill. You are gaining a legitimate programming superpower. The ability to make applications that can actually remember things. This changes everything. You can save a player's high score, you can create a settings file that remembers a user's preferences, you can log events. The wall between your program's temporary memory and permanent storage on the computer is now gone. So the only real question left is, what are you going to build first? Thanks for joining this explainer.